This video is about using geometric constraints in order to properly locate and shape a profile based on particulars that we know about. Okay, so we're going to work through the different geometric constraints. You should have the sheet in front of you, that again, or have it up on your screen. I'm going to work through these with you right now, and then after this tutorial, I'm going to ask you to go back and actually show me that you can also do these on your own. So firstly, so go ahead and take a second, pause this on your screen. All right, stop the video and make a shape similar to this. Okay. Once you've done that, we're going to start looking at the different shapes. So notice that all these lines are not vertical, horizontal, perpendicular, parallel. Dealing with lines, these, okay, so horizontal, vertical, perpendicular, and parallel, these four you can use a lot. Okay. So take, for example, this line right here. Say I want that to be straight up and down. Okay, I can make that, I can give that a vertical constraint, and notice that now it is straight up and down per my x, y axis. So based on the y, it's going straight up and down. Now if I want to make a horizontal constraint, quite simply, I click on the horizontal constraint that's up here, if you're questioning which one it is. Okay, and I can then click on this line and make that horizontal. Okay, notice those. Now, there's an inferred constraint based on that. These two now are, because this one's horizontal, this one's horizontal, this one's vertical, they are now perpendicular. So if I was to try to put in a perpendicular constraint on this side, it would actually give me a warning. Okay, and say, hey, listen, buddy, this constraint will over-constrain. You've already done this. It's implied. Okay, but what I haven't done, though, is on this side, with the bottom and this side. If I want that to be perpendicular, now those two lines are perpendicular. Okay, so far we use the horizontal constraint to make this one straight across flat. We use the vertical constraint to make this one straight up and down, and the relationship between these two now is perpendicular. Okay, horizontal, and it has to meet, though, that line has to meet this line at some point. Okay, now we also have parallel. Now please note that these lines by default, because they're connected and vertical, are also parallel. But we could use the parallel constraint to make this line here and this line here also. Notice that they are now parallel. Okay? Alright. Now, we've done this whole line here. I could do the same thing for this line, but I could also use my collinear. Okay? Lying across the same line to straighten those out. So notice how I just took that down. Collinear meaning lying along the same line. Okay? Both, okay, are along the same line. Now, I have defined this. If I want to go in now and give it dimensions particular to the sides, full side lengths, I could do that. I can also use equal. It will be implied, though, at this point. If I click equal on these two or these two, it's going to be implied based on what I've given it so far for geometric constraints. Okay, so you've got to watch out for that. What I'm going to do, though, instead is come in here and make another, let's make instead, I'm going to make a circle instead. Okay, so go ahead and make we're going to make a couple circles. Okay, so we got two circles here. All right, now I'm actually going to get out of the circle making business here. I can make this, notice that until I've given it a dimension, I can make them smaller. I can move it around wherever I want. But I want to constrain this, and I want to place this circle, I'll make it a little smaller actually. I want to place this circle inside of this circle. Okay? That is when we're going to use, if we have to do anything like that, we're going to use a concentric constraint. And what that says is that it's going to constrain any two arcs, circles, or ellipses to the same center point. Okay? So I'm going to click on this circle, click on this circle. Okay? And then notice that one is brought into the other. It's based on the other point. Now, if one of the circles was fixed in a certain location, we either geometrically constrained it or dimensionally constrained it, it would go, the one circle would go to the other circle. the unconstrained would go to the constrained circle. Okay, but notice that that's what it does. The concentric constraint will places both of them together. Okay, use the same center point to place one circle based on another. Okay, this could also be for an arc. Okay, you could place a circle within an arc using the arc center point too. Now, we also haven't yet used our coincident constraint. The coincident constraint will take in place, will connect 2 points. Okay, it could be the end point of a line, okay, could be the center point of a circle. And let's place this circle, okay, these concentric on that point there. Okay, notice that how I can move those over just by clicking the center points, the end point or the vertex of these two lines, that point, and the center point that made up our concentric circles here. Okay, now we have this information. All right, we've got a couple other ones here. Now, at this point, I haven't given anything. If I want to make both these circles equal, I could do that. Or let's do this. Let's do this instead. Let's make a circle over here. Okay. If I want this circle, all right, click OK. If I want these two circles to be equal in size, say I have dimensioned, say I have dimensioned that circle to be 1, okay, and I want this circle to be the same, have the same diameter as this circle, I come in here and make them equal, okay, and notice how this will then be 1 as well. Okay, I don't have to make that dimension because it's already constrained. It's already got that constraint identified, so we don't have to actually make that. Okay. Notice how it's a driven dimension now. So we've got equal, tangent. Now, tangential means contacting at one point. So if I need this circle to contact or be tangential, meaning it would make a contact with this side, say, I'm going to click tangential, click on my circle here, and identify the side, okay, the straight line that I want to be tangential with. It could also be tangential to another circle. So I could place it like that. And notice how it only contacts at one point. All right. Okay. And again, I could also make it tangential to that side, whereas it's tangential to both of those sides. Okay.